Hi, I'm going to talk a little bit about the morality and bring some science and physics into it. It's always a dangerous, sensitive subject, morality. It's being used for manipulation a lot, and it is used for manipulation a lot. And the form there is always like, I have some arbitrary subjective rules that benefit me, but I present them as objective moral rules that you ought to follow. People are very sensitive in respecting universal rules because they're in nature everywhere. Laws of nature. So we are built to find and respect universal rules. But nonetheless, it is a good idea to think if we can find some really objective rules for behavior. So the definition of morality I start with is universal rules of human-human interaction. So that is different from the dictionary in the sense that there's often says the average out opinions or the general opinion about human behavior. But I think you cannot average out opinions. You cannot take a general opinion. If someone thinks it's okay to murder and someone else thinks it's not okay to murder, how do you average this out? You cannot do that. It's also not what you do in science. So you're not gonna say yeah, this scientific theory is true because so and so many people think it is true. That is not a valid way to test a theory. Now, what are the objections if you bring science into morality? You often hear is the first reaction, and that comes really quick often, is that science is descriptive and morality is prescriptive. And there's also another one of David Hume. He says there's an is-ought dichotomy, and you cannot get from something that is to something that ought to be. I think these reactions are remarkably fast, and I think there's something intuitively I say that is wrong with that. If the reaction is so fast, it is not well thought over. What is meant with this is-ought dichotomy? Well, you cannot get from an is to an ought, and I think yeah, you can. I can agree with that. And it is also that you can get from an if to an ought, and an if is the way. So if you want to be healthy, then you ought to eat vegetables. But notice that this relies heavily on a lot of is also, because it is relying on the is that there are vitamins in vegetables, and that your body operates on using these vitamins. And there's a lot of is that brings you from this if to this ought. Now, I think the way you can use it is, you can say you can go from an is to an what ought not, and I hope I can explain this a little bit further on. Now, universal principles, science has done a lot and finding universal principles, and one thing that has always gone wrong with science and was proven to be the wrong way to go is to have principles that are that require some sort of super perspective that is more valid than another perspective. So yeah, a universal frame of reference that is required, and that is somehow above other frames of reference. And in science, that always proved in the past the wrong way to go. It started basically with Galileo, at least that I'm aware of. Galileo said that at that time only the mechanical laws were known, and he noticed that when you were standing in the hull of a ship and you couldn't look outside, then you could not do any experiment, dropping a coin or throwing a ball or swinging a pendulum. You could not do an experiment that could prove that the ship was in motion or was at rest if you had a quiet sea. So steady motion did not affect the laws of mechanics, and that's why he also said that these rules are independent of the frame of reference of the observer. So whether you're in the harbor or you're moving with respect to the Earth, the rules stay the same of mechanics. That is indistinguishable. Newton then, still only talking mechanics here, started to have a problem with that, because, well, we all know that if you sit on an office chair and you rotate, then your arms, your limbs fly outward. Centrifugal force is often named. And Newton was wondering, suppose you are in completely empty space, far away from all the planets, and you're not seeing anything, no stars, no planet, you're just in complete blackness. And if you are spinning around there, do your arms also fly outwards? And more importantly, what does it mean if you're completely empty space that you spin? Because you compare to what? Normally, if you spin in a room, you see the room spin around you, and that's why you know, okay, I'm spinning because everything around me moves around. But if there's nothing around you, how can you tell that you're spinning? And Newton then said, you know what we do? We make a super perspective, a frame of reference that is fixed to the stars, and when you're rotating relative to that super perspective, that super frame of reference, then you're really rotating, and that is when your arms fly outwards. And yeah, that is a clever solution, but a little unsatisfactory, because why is that perspective so special? And Ernst Mach, who is known from the speed of sound, Mach 1, Mach 2, Mach 3, but he noticed that there was a difficulty in this super perspective, and what he did was say, well, I think that when you're in complete empty space, when there's no mass present in this space, and you rotate, you cannot really tell. Rotation doesn't mean anything, and your arms will not fly outward in this situation. Now, when you put a little bit of mass somewhere in this empty space, then you can notice that you're rotating, and your arms will fly outward to the amount of mass that is present in this universe. And if you have all the mass that is currently present in the universe, then you will have the amount of flying outwards of your arms during rotation that we presently experience. And Einstein was very charmed by this view, because it did not require a super perspective, not a special frame of reference, and Einstein was also very into that. We'll see later. Einstein later abandoned, by the way, this view of Ernst Mach. Now, when electromechanical laws were discovered by Maxwell, he discovered that the speed of light, light as an electromagnetic wave, is always 300,000 kilometers a second. But the question was, speed compared to what? Compared to what are these waves going with this speed? And yeah, what they did again was introduce a super perspective. And that again proved wrong. They introduced something called ether, and they said, okay, everything goes with the speed of light relative to that ether. And they tried to do some experiments to prove that, and they stuck with that a very long time, and all in vain basically, because Einstein destroyed the whole idea of the super perspective, and he said for all observers in relative motion, it's irrelevant what your perspective or your frame of reference is, the speed of light is always constant. And basically what he said before, that all the laws of nature are valid for all observers